Hello, my name is Michel Destu, and today I'm going to make an introduction on how to visualize GIS data in your iTwin. In this session, we're going to discuss on why you would like to have GIS data in your iTwin. We're going to discuss about two different approaches, so referencing or synchronizing GIS data. I'm going to make a quick overview of the iTwin GIS API and then a demo. And at the end, I'm going to provide links to get more information on the topic. So why GIS data? So any projects, whether it's transportation, nuclear, or buildings, will require information that goes beyond the information of a single asset. And very often, the first step is to locate your project on a map. And then you might add layers of information, for example, land use, geology, or maybe weather information. And by doing that, you create your context for your iTwin. That will eventually help you in your decision-making process. So you might ask, why not simply use reality data instead? That's a good question. Uh, Reality data offer great realism and is also already well supported by iTwin. But for some projects, GIS data is simply just more accessible, and it's just another option you have. So there are two main approaches when it comes to visualizing GIS data in iTwin. The first one is synchronizing your data in your iModel. So you can import directly your data in the iModels using what we call iModel connector and the iTwin Synchronizer tool. By doing that, your data will be published by the iModel Hub, and you will benefit from the versioning and the tile format publishing. The other option is referencing your GIS data. In that case, data is going to be accessed directly from your web service in the iTwin viewer. So there is no import of data involved. That can be achieved in using the iTwin GIS API or the map layer widget. In this session, I'm going to spend most of my time on the second approach, which is referencing GIS data, mainly with the iTwin GIS API. So the main concept of the iTwin GIS API are the base map and the map layer. The base map is also referred as the background map. There are two possible definition for the base map, so solid color or imagery layer definition. There are two built-in provider, Bing Maps or Mapbox. We also support the 3D terrain. The map layers. So the map layers are additional layers of information you can add. Those layers can be displayed in two different ways. So background layers, which are always displayed below all iModel geometries, or the overlay layers, which are displayed on top of all iModel geometries. The map layer display order is controlled by their relative position in the map layer list. There are two sources possible right now for the map layer. So it can be an imagery layer, or if you prefer raster tiles. In that case, as I said, we support Bing Maps and Mapbox. We also support OJC services, so WMS, WMTS. We support the Esri RGS map service, and also any Google Maps compatible tile map service. There is also another possible source for the map layer, which is a model of the iModel. I'm going to make a quick demonstration of that in the next few minutes. Few things to keep in mind with the iTwin GS API. The base map and the map layers API are part of the view display style, which means that each view gets its own independent configuration. So you can have two different configuration if you set up two different views, right? Other things to keep in mind, map box, Bing Maps, and also the season terrain require access keys that you need to provide. Coordinate system are limited to APSG 3857 or APSG 4326. And also we are subject to the browser course policy. So uh, in most cases, we're going to be making cross-origin requests with the GIS web services. So the server needs to be correctly configured to provide the right access control allow origin header. All right, so that covered most of what I wanted to discuss. So let's have a quick demo on all of these. Okay, so for this demo, I'm going to use the developing a web viewer tutorial from the iTwin GS documentation. Basically, all you need to do is call this command here and specify your own application name, and then you follow the different steps. You will need to register your application in the developer portal and then do some setup. When it's done, you should get something like this. Here, I picked the metro station um, model because it's geolocated. Also, I created a very simple background map and map layer widget with few buttons that we are going to implement together. Okay, so the first thing you will notice in your application is that there is no background map, even though your model is geolocated. So the reason for this is that you have to specify your own keys for those provider. So let's do that together. So if I go in my project right here, I suggest that you use the provided .env file, okay, and you create a key value pair for Bing Maps, Mapbox, and the season key. Okay, by using the .env file, we'll make sure that your access keys never end up in your file repository. When it's done, you can go back in your app.tsx application. I suggest you create uh, React state for the different values like that, and then you go on the viewer component here, and you set your keys on the different properties for Bing Maps and Mapbox that need to be set on the map layer option like that. And for the terrain, you need to set your key on the tile admin property. So if we save that and go back in our application, reload, we should get the background map now. Okay, very good. We can see the Bing background map. Okay, so now we will try to change the background map. So we will implement those three buttons here. Okay. So as a first step, we will simply try to change the background map to a solid color. Okay. So for that, I'm going to set the background map base object of the display style. So if we look together into the definition of this object, we will see that it's defined as either base map layer settings or a color depth. Okay, so for that button, we will set that to a color depth. Okay, so we simply call the from. We set the different channel values for the color. So here it's going to be solid blue color. Okay. Also, we will implement a button for changing the background map from Bing to Mapbox. Okay. For doing that, I suggest that you call the change background map provider method on the display style. Okay. This is a utility method, and that lets you specify either Bing or Mapbox. And then you can specify the style of the background you want to display. So we expose aerial, hybrid, or straight. So let's pick aerial. And for the third button, we will try to switch to a custom background map. So in that case, it's going to be Open Street Map. So that can be achieved like that. So as we saw previously, the background map base can be a color depth or a base layer, a base map layer setting object. So to create a base map layer setting object, you can call the from JSON and specify the different properties. So you need to specify a format ID. Okay, the format ID is defined if you look into the map layer settings file. There is a imagery map layer format ID that is defined here, and that gives you the list of supported format IDs. So we support ArcGIS, Bing Maps, Mapbox Imagery, Tile URL, and WMS and WMTS. In our case, we're going to pick Tile URL, and then you need to specify the base URL of your service. And in case of a tile URL, you also need to specify 3 runtime parameters that are level, column, and row. Okay, and those runtime parameters are going to be replaced by the API at runtime with the proper values. We also need to set the name. Okay, that can be any custom names. Doing that will give you your base map layer setting object, okay, that you can set on the background map base of the display style. So let's save that and reload our application. So by default, we get our Bing Maps background. So if we click on the solid color, we see we get a nice blue background map. We can click on the Mapbox aerial that gives us the Mapbox background, and then the Open Street Map will change. Okay, that's very good. If you look at closely the model here, you will see that it seems that the model is floating a little bit on top of the background map. And the reason for that is that by default, we always make sure that the background map is drawn behind the eye model, okay? If you want to have the proper elevation for the background map, you need to turn on an option that we call use depth buffer, okay? Or the other option is to turn on the terrain. So let's implement those two options with the buttons here. Okay, I already have my buttons here. So let's take the implementation here. Okay, so the use depth buffer is on the background map settings of the display style. So just one quick note, okay? Most object on the view are immutable, which means that you cannot directly change its value. So for example, if I want to change the use depth buffer option and set that to true, for example, we will get an error that says use depth buffer is read only. So instead, you need to use the proper method for changing it. In that case, okay, we can call the change background map props method, okay? So for this demo, I'm going to just take the actual value of the use depth buffer property and I'm going to change it to the opposite value so that we get a nice toggle button. Let's do something similar with the terrain. So display terrain is also on the display style. So again, we take the display terrain value from the display style, okay, and change that, call again the change background map props and set the opposite value, okay, of the terrain. So if we set that and reload our application, all right, zoom in just a little bit and click on the use depth buffer button, we can see that the background map has now the right elevation. Let's try the terrain now. Okay, we can see that the terrain is correctly displayed and we get variable elevation of the terrain and that the model is correctly displayed. Very good. Okay, as a next step, we're going to add another layer of information to our iTwin. Okay, so let's see how we can do that. So I'm going to add a layer from an Esri server. Okay, so we can take this code. Okay, so similar to what we did for the OpenStreetMap, we need to create a setting object. Okay, for the map layers, I suggest that we use the map layer source object. Okay, the benefits of this layer is that it will validate for you your layer definition and give you a nice status. Okay, and you will know that the remote service can be correctly accessed and there is no authorization issue, for example. Okay. So to build our map layer source object, we need to specify a name, format ID again. So here we specify our GIS. We're going to provide this endpoint URL. This is our GIS Online endpoint, and use that to and pass it to the from JSON that will give us our map layer source object. We call the validate source and check the result. If it's valid, then we can transform our source into a layer settings. Also, when you do that, you can use the sublayer that has been discovered part of the validation process to build your layer setting object. And when it's done, you simply need to call the attach map layer method with your setting object, and you specify if you want your layer to be an overlay or a background layer. Okay, so if we save that and go back in our application again, okay, so we can click on the attach layer. We can see that the layer of information, okay, appears correctly. That's very nice. Um, so before the presentation, I imported the data from a GeoJSON. Okay, I use the iTwin Synchronizer tool to do that. So that created a model in the iModel, okay, which is Philly traffic volumes, okay, and that give us those lines you can see. If I turn on the terrain, um, you will see that there is a small issue with the lines because at some point we can see there the blend with the background, okay? So the reason for this is that the GeoJSON data I imported was in 2D, and here we have a 3D scene, right? So if we use the location tool, we can confirm that. We can see that the line has been created at an elevation of 0, And if we look at the background map, here it has a negative elevation, so that allows us to see the lines. But if we go here, the background map has positive elevation, and this is why the lines coming from the JSON disappear. So there is a way to solve that. Okay, we can transform our model into a map layer. Okay, let's see how we can do that. Okay, so I got some implementation already. So the first thing we need to do is find the proper model object in the iModel. Okay, so what I'm going to do here is simply query the iModel for all spatial location model. I know that my GeoJSON has been imported into this type of model. And for each model we find, we're going to create a model map layer setting object. Okay, a model map layer setting object is simply created by providing a name and the model ID of the model. Okay, and when we got our setting object, again, we can call the attach map layer method that takes the setting object, and also you need to specify if it needs an overlay or background layer. Okay. Uh, One note here, we also need to turn off the model display, okay? Because we don't want to have the model itself and the layer representing the model to be displayed at the same time. So I'm going to save that, reload the application. Okay, if I turn on the terrain again and turn on our GeoJSON data, okay? And now I'm going to click on the attach model layer. We can see now that the GeoJSON model is correctly displayed because it has been transformed into a layer, okay? And it's now correctly aligned with the background map, okay? Um, so, and we can also see that the the lines are also draped on the terrain correctly. All right, so a very last thing before we end this demo, okay? Um, there is a map layer widget, okay, that is provided by iTwin, okay? So let me show you how you can install that in your application, okay? So all you need to do is install a new package, okay, called the iTwin map layer package like this, okay? You can run npm install easily for that. And when it's installed, you need to initialize the widget, okay? So you simply need to call the map layer UI object and call the initialize method. So if I save that and we go back in our application, okay, you will see there is a new icon that appears here. This is the map layer widget, okay? So as you can see, there is already a nice UI, okay, that will give you the list of currently active layers, the background one, the overlay one. You can change your background layer from here. You can set the different uh, background map settings and so on. You can also add a new layer from here. Okay, so all of that is available. So if you want to save some time, you can simply reuse the map layer widget. I think that's it for the demo. Thank you. So in this session, we saw two different approaches to visualize GIS data in your iTwin. So you can either synchronize your data or reference it, okay? We saw the main concept of the iTwin GIS API, the base map, and the background overlay map layers. And we also So how we can use the iTwin GIS to change the background map or add different layers of information. Here are a few links, okay? The getting started tutorial, the DisplayStyleState API reference, the iTwin Synchronizer if you want to synchronize your data, and also a link to the support of iTwin community. Also, you can use this link to register your developer account. Thank you for watching.